Okay, welcome to CIX 1003, and this is your business statistics. Okay, today lecture we will discuss about two samples test of hypothesis. Okay, so last week we have discussed one sample test of hypothesis. Okay, and we will discuss this week on two samples test. Okay, and how we're going to develop the hypothesis and find a statistical test on this such a set of data. Okay, all right. So today lectures contents will be on this. Okay, first we're going to do a test hypothesis. Okay, with the two independent populations. Okay, two independent populations for the mean equal, and then assuming that the population standard deviation are known and equal. Okay, so the population standard deviation are known and equal. So these are the conditions. And then we're going to do the test hypothesis for the two independent population on the mean equal with unknown population standard deviations. Okay, so first we already know this, that population standard deviation, and then for the next, we're going to calculate when we unknown the population standard deviations, how the analysis can be carried out. Okay. Next, we do the test hypothesis about the mean population difference between the pair, or also we call as a dependent observation. Next, we're going to explain the difference between the dependent and independent sample. So what does it mean that dependent and the independent samples? So it's what we're going to discuss in this lecture. All right. Comparing two population. Let's see what does it mean the comparing two population. Okay. So first example, you can see that is there difference? Is there difference in the mean value? Okay, in the mean value of the residential area, residential real estates sold by male agents, okay, and the female agent in South Florida. So that means that, so we're going to see that the difference between by male and female, okay, male and female. So that is a two different, two population. Two different set of data that we're going to consider. Okay, so that means your mean, the keywords in order to analyze that or develop the hypothesis, you need to know that is there difference in the between mean value of residential real estate sold by a male agent and the female agent in South Florida. So that is a hypothesis statement. Next, is there difference in the mean number of defect product produced on that day and afternoon shift at the Kimball product? So we see that we find that the hypothesis, we write the statement. Okay, so two things. One is the defect produced on the day, okay, on the day, and remember, and the afternoon shift. So these are two different things. Okay, so we need to collect the data or samples between these two, set of population of data, and then we run the test. We run the test. Normally, we depend on the number of samples we have. We run that the statistics test. Okay. Third example, again, moreover, similar look like the first two. So is there any difference? Is there a difference in the mean number of days absence between young workers under 21 years old and old workers. So these are two different populations, okay, in the fast food industry. So the fast food industry, that is the area, so the area that we collect the data, okay, in the fast food industry. So the main two different test sample is, one is young workers, another is old workers, okay, or older workers. Next, is there any difference in the proportion of the Ohio State University graduates? Okay, okay, so Ohio State graduates and the University of Cincinnati graduates. So that means they are referring to the two different universities samples, okay, who passed the state certified the public accountants examination on their first attempt. Okay, all right. So we need to collect the data for those who passed the state certified public accountant or CAP examinations on that their first attempt. So data is come from Ohio State University and the University of Cincinnati. Okay, so there's two different set of data. Okay, next, is there an increase in product rate if music is piped into production area? Okay, so well, this is something whether we have two things. Is there any increase production rate of if the music is piped into production area? So increase or decrease. So we take the two things, all right, two set of data. So this is the sum of the example, all right. So that is even more. So this is just give you pictures that you can easily identify how you can develop the hypothesis based on the two sample test, right? In order to analyze the statistical analysis. Okay. Now, comparing two population means for the case mean is equal, and then is known population variances. Okay. So the non-population variances, that means we already know that the variances for the populations. Okay. So now the learning outcome of this topic, we will focus on test hypothesis for two independent population. Okay. So we're going to test that the two independent populations, which is the means are equal. Okay. So the means are equal. So the mean value is equal, assuming that the population standard deviations are known and equal. Okay, so we already know that. You should know that the population standard deviation is equal for the first sample and the second sample. Okay. Okay, there is no assumption about the shape of the population are required. Okay, you should know that there is no assumption. Okay, there is no specific assumption about the shape of the populations are required. And then the sample are from independent population. Okay, so usually when we collect a data, all right, so it should have, I mean, the sample should have from that the independent populations. Okay, now next is a formula for computing that z value. Okay, so yeah, I'm sure you all know the distribution value. Okay, so we can draw on that when for this case comparing two population means. So it is the standard deviation is equal. Okay, we already know that standard deviation equal and known. So for that case, the formula is z equal to mean 1. Okay, this sample means minus sample means 2. All right, there's another set of data over square root of, and then this is standard deviation, or sorry, variance for the sample 1 and variance for the sample 2 over, and 1 is referring to that the first set of data, and then the N2 is for that the second set of data. So you need to choose the correct corresponding set. Okay, so this is referring to the first independent first set. This is the second set, independent samples. Okay, so I want you to remember this formula and try to memorize it. Okay, so it's what we're going to use in that tutorial in order to calculate that values for the z. Okay, the normal distribution values. Okay, now take a look this example. Okay, how are we going to solve the one of the statistical problem with that the case of the standard deviation are equal, okay, and known. Okay, all right. So we're going to use that the z distribution for this case, okay, and see the procedures what we should carry out in step-by-step order. Okay, so given that the fast lane producers was recently installed in local food market, okay. So remember, whenever you go to supermarket, there is the regular line, you know, the payment counter, okay. The payment counter, there is a when you're paying money, okay. So there is a one is regular line, another is a faster line. The faster line usually maybe they said that you know the self-pay makers or self-service payment can be made on the computer, all right, or there will be the the items is less than maybe 10 items, all right, so that the line will be much faster than the regular line. Okay, so say that is they already installed in the local market. Okay, the store manager would like to know if the mean, you need to careful, you need to know that the mean checkout time, okay, the mean checkout time using the standard checkout method is longer than using fast line produced. Okay, so they want to know, the store manager want to know if the mean checkout using the standard checkout method is longer than, okay, is longer than, underline all the keywords, okay, so it's longer than using that fast lane procedure. Okay, now she gathered that the information, okay, following sample information, then the time is measured from when the customers enter the line, okay, until their bags are in the cart. Okay, so the cart, which means they keep here. Okay, all right. And the time include both waiting in the line and checking out. Okay, now, so the time is include both waiting in the line as well as the waiting, checking out. So that means this entire time. Okay, now we have some informations, all right, based on these events and the managers have collected. And as we all know, all right, the population standard deviations already given, okay, and then the sample mean so already know, okay, and the customer, okay, we need to know that because our objective is we need to evaluate, okay, the standard checkout method is longer than using the fast lane method. Okay, so we just make it simplify the standard and then the fast lane. Okay, so as we know the standard, the sample mean is 5.5 minutes. And then for the fast lane is a 5.3 minutes. And the standard deviation, if you could see that for the standard checkout method is a 0.4 minutes. Okay. And then for the fast lane is a 0.3 minutes. And then the sample size. So for the sample size, for the standard, they choose about 50 people or 50 customers. Okay. And for the fast lane, they choose about 100 customers. Okay, so these are the information we have at the moment. Right now, we need to initiate the statistical analysis. Okay, by writing that the hypothesis statement. Okay, here we go. All right. Once we just look at that your table and all the information, or so we call it data. So now you're going to do the statistical analysis on the data that we have. So first thing first, what we all need to do, we need to apply the 6 steps, the what I taught you last week. Remember, so you should carry out the procedures, the step by step order. Okay. All right. Now, our main objective is we're going to test the hypothesis. Okay. And we need to know that the first step is you need to write that the null and alternate hypothesis, or a null and an alternative hypothesis. As we know just now, we read that the keywords longer than. So whether the customers line up in that the standard checkout, lane is longer than the fast lane. Okay, so since that the keyword is longer, so then you should know this is come up with the statements, okay, less or equal or greater than equal. Okay, now we're going to prove this, the alternative. Okay, as I said right earlier, always remember we're not going to prove that the null statement, but we're going to prove that the alternative statements or alternative hypothesis. Okay, so as we know, the customers who line up in standard checkout is greater than uh, the fast lane. Okay, so we just initiate that H1. Okay, the hypothesis 1 or hypothesis alternative is the mean for the standard lane is greater than the mean of the fastest lane, okay, or fast lane. Okay, and then you should know that the null hypothesis, you can draw this way. The null hypothesis is always against to the statement that will be written in the alternative. So the mean of the standard checkout time is less or equal with the mean of the fast lane. Okay, so this is the first thing you have to do. Okay, next, once you've done this, now you need to set the significant level or level of significance. Okay, so in these questions, the significant level is 0.01. Okay, it's requested. Okay, so that means we just we stick to that 1%. Okay, for the level of significance. Okay, step 3, we need to determine that appropriate test statistic. Okay, now, so we should consider what type of the test statistic we should consider for this data. Okay, now we know the set of data, okay, for the standard lane is given is 50 just now. Okay, and for the fast lane is 100. Okay, if you can see that this is more than, okay, 30 sample. Okay, more than 30 sample. If less than 30 sample, then we have to use that the t test. Okay, if it is more than our t distribution, so if more than 30, then we consider the z distribution, normal distribution. Okay, so that we're going to use that the z distributions as the test statistic. Okay, now moving on. Once we determine the step 3, now we're moving to the step 4. Step 4, we need to formulate the decision rules. Okay, you need to formulate the decision rules. So we need to know that if we should reject that the hypothesis null, say the condition is the z value that we obtain is greater than the z value at the significant level, okay, the critical values, okay, the alpha value. Okay, so alpha, so now as we know that is a 0.01. Okay, so we should know if it is the value of the z is greater than the critical the z value of the in the critical region, So, and critical value, so then we have to reject the hypothesis null. Okay, so now as we know that the alpha is 0.01, you can check in that the table. Okay, so when we look at the z distribution or number distribution table, we can obtain the rejection region is a 0.01, so which means this region is 1%. Okay, so at the point, the critical region 0.01, all right, so the z value is 2.326. Okay, so in other words, we also can give like this. Okay, z equal to, okay, so the critical value is 0.01, so which means the value at this level of significance. So we know that the z value is 2.326. That is a critical value at this point. Okay. All right. So once we identify that, okay, now we do the test statistic. Okay, the z distribution. Okay, moving on. But you need to remember, you need to how to draw all these things, guys. So this is US for the standard lane. Okay, and you mean mu F is the fast lane. So you should know all this, the how to draw the diagrams. Next, once you've done that, go back to the step 5. Okay, initiate the step 5, which is take a sample and make a decision. So we need to consider the sample test we have. So this is the sample. Okay, we have, and then we need to design or need to find that the z distribution values. Okay, how it should carry out? So we know the formula for the z distribution. Okay, so just now we discussed. So z equal to mean standard mean value of the standard lane, and then the minus with the mean value of the fast lane. Okay, so the fast lane, we already know that is a sample mean is a 5.3. Okay, and then the standard lane is a 5.5. Okay, so I just read it right on here. So this is your standard lane, and this is your fast lane, or maybe U or F. You can set anything as you want. And then the square root of the population variance, okay, over the number of sample in that your standard checkout line, plus the variance of the fastest lane over the number of sample in the fastest lane. Okay, so as we know that the population standard checkout lane is about 0.4 minutes, so you just substitute the variance here. Okay, so we know the standard deviation is 0.4, so we just substitute here 0.4. And then the population standard deviation for the fast lane is 0.3. So we just substitute here as 0.3 and square in order to just get the variance. And you need to divide it by the first line is a 50. Okay. So we know that N1 is a 50 and N2 is a 100. Okay. So you just solve, simplify it, you get a 3.123. So this is your Z scores. Okay. So now your z-score is 3.123. Now, once you get the z value, you need to compare with the critical value that you obtained just now. Okay. Now, as we know that the z value, okay, is a greater than or larger than the critical value, which is your z alpha. Okay, your z alpha. So, and we decided to reject the null hypothesis. Okay, so we make a decision in order to reject the null hypothesis. Okay, because that the 3.123 is greater than 2.326. So which means you can see that in okay the graph. Okay, so the value we already said that we already we have to reject that value if the z value is greater than 2.326. Okay. Now, so next step 6, we need to interpret the result. Okay, so we should know how to interpret it. So the interpretation suggestions, we can do that. The difference of the 0.2 minutes, okay, so 0.2 minutes between the mean checkout time using the standard method is too large to have occurred by the chance. Okay, so we can conclude that fast lane method is faster. Okay, or fast lane, the checkout is faster.